Chapter 11. The demon pays its debt. Thermodynamics of coherence. Breathe in deeply, like someone preparing to face an accusation. The previous chapters built something beautiful, a sea field that protects coherence, that crosses impossible boundaries, that unifies scales. But there was a question we avoided, an uncomfortable question, a question that, if left unanswered, could bring everything crashing down. The question is simple: where does the energy come from to protect coherence? Or put another way, where does the noise we filter go? This chapter faces that question, and in doing so, discovers something profound about the nature of protection. The accusation. Imagine a prosecutor in a trial. He has patiently listened to the entire presentation of the sea field, the data, the predictions, the elegant mathematics, and then he stands up and says, "All very nice, but you have a problem. You say the sea field protects coherence by filtering noise. Very well. And where does that noise go? Does it simply disappear? Because if it disappears, you're violating the second law of thermodynamics. And if you violate the second law, everything you've built is a fantasy." Silence in the courtroom. The prosecutor is right. Philosophical box. The second law does not negotiate. The second law of thermodynamics is perhaps the most democratic law of physics. It makes no exceptions. It doesn't matter if you're an atom or a galaxy, a qubit or a brain, a laboratory experiment or the entire universe. Total entropy never decreases. Disorder never spontaneously reduces. If you order something here, you must disorder something there. There's no free lunch. Many beautiful theories have died against this rock. Perpetual motion machines. Demons that violate physical laws. Dreams of infinite energy. If RCD wants to survive, it must pay its debt to the second law. Maxwell's demon, a story of redemption. In 1867, physicist James Clerk Maxwell proposed a thought experiment that seemed to violate the second law. Imagine a box divided into two compartments by a wall with a small door. Both compartments contain gas at the same temperature. A demon, a tiny, intelligent being, controls the door. The demon observes the molecules. When it sees a fast molecule approaching from the left, it opens the door and lets it pass to the right. When it sees a slow molecule approaching from the right, it opens the door and lets it pass to the left. Over time, fast molecules accumulate on the right, hot, and slow ones on the left, cold. The demon has created a temperature difference without spending energy. It has reduced entropy. It has violated the second law, or has it? The solution. The demon must pay. For over a century, brilliant physicists worked on this problem. The solution came in two parts. Rolf Landauer, 1961, showed that erasing information has a minimum energy cost. W_min equals KBTLN2. For every bit of information you erase, you must dissipate at least this amount of energy as heat. Charles Bennett, 1982, completed the argument. Maxwell's demon must remember which molecule it let pass. Its memory fills up. Eventually, it must erase that memory to continue operating. And that erasure costs energy. The demon pays its debt. It doesn't violate the second law. It only displaces it in time. It accumulates an entropy debt that must eventually be settled. Technical box. The Landauer principle. The Landauer limit establishes that erasing one bit of information requires dissipating. W_min equals KBTLN2, approximately 3 times 10 to the minus 21 joules at room temperature. This seems insignificant, but multiplied by billions of operations per second, it becomes the heat your computer dissipates. Profound implication. Information is physical. Processing it has a thermodynamic cost. Free information processing does not exist. The sea field has demon. And here is the revelation that closes the RCD program. The sea field is a Maxwell's demon. Not literally, of course, but functionally. It observes the noise threatening coherence. It filters selectively, blocking harmful perturbations. It preserves the coherent states we want to maintain. And like every demon, it must pay. The architecture of payment. How does the sea field pay its debt? Through the N signatures we already know. N1, memory, equals work reservoir. The system's non-Markovian memory stores information about past correlations. This information represents free energy, potential work that can be used to filter noise. But maintaining that memory has a cost. N2 protection equals entropy valve. The protection mechanism acts as a valve that directs entropy flow. When noise arrives, the valve closes to the system and opens toward an external bath. Operating that valve requires work. N3, emergent scale, equals temperature differential. The emergent scale delta defines an effective temperature. For protection to work, there must be a thermal gradient, a colder place where entropy can be deposited. Without that gradient, no protection is possible. Reflective box, no magic, only accounting. There is something profoundly honest about this picture. C field is not magic. It doesn't violate physics. It doesn't create coherence from nothing. What it does is redirect entropy. It takes the disorder threatening the system and channels it toward an external bath. It doesn't destroy noise, it exports it. Protection of coherence is not destruction of entropy, it's redirection of entropy. The system stays ordered because it pays the price of disordering something else. The second law is satisfied. The demon pays the ledger. To make this concrete, let's build the entropy ledger. Process entropy change where noise generated plus delta S, hot bath, noise intercepted minus delta S. Demon C field, demons processing plus delta S underscore D. Demon export to cold bath plus delta S underscore C cold bath. Protected system approximately 0. System total greater than or equal to 0. Checkmark. Second law. The system maintains low entropy, high coherence, because the demon absorbs incoming entropy and exports it to the cold bath. The total cost is positive. The universe's entropy increases, but the local system remains protected.